Alright everyone, so hopefully we are live. I'm just taking a look here. Yep, looks like we are live. And we're just going to continue on these wiki.repair articles that we've been working on and go from there. So this is the A2237. We did quite a bit here. We just need to finish up a little bit here. So let's see here. Got to figure out what we have left. And then I do see a little mistake here that I do want to correct. So we are going to fix this. This should not say this. This should just be A2237. And I want this to be a little bit... it doesn't need to be. That's fine. I just don't want it to say no sound from speakers there. We don't need to save it yet. And let's continue. So let's go down. Okay, so we are at the end of this particular article. Okay. Alright, so we're talking about support voltages for the CD3217 on the M1 boards. That has been drastically different. So let's go ahead and take a look at that. I am going to silence my phone because there's something that I don't really want to deal with right now. Okay, so looks like we left off on troubleshooting 5VS2. Okay. Do diagnostic steps. And if you can't tell, this is going to be a boring stream, but that's okay. Okay, so 5VS2. We in the repair steps yet, or the diagnostic steps? Because I just confused myself by looking at this. Gotta love it when you get confused. Here we go. This is what I want. Yeah, so 5VS2 is really the only practical voltage I've seen missing on these. The rest, it's created by PMICs, can be firmware. I mean, it's still very fresh, so we don't really know 100% how they'll present when those are missing. Let's see what I have written down here. Okay, so we have 5VS2 produce from UC3000, check for a short to ground. That's the most practical thing to do because most cases are going to be a short to ground. If no short to ground is found, proceed to the next step. Check the enable signal for PP5VS2, which is P5VS2EN. It's produced by the PMU. If it's missing, it can be a firmware issue. I mean, it can be anytime you have PMICs sending out enable signals, it can really be caused by pretty much anything. So that's generally just something that, you know, I don't really like to troubleshoot, but it comes to it sometimes. So missing enable can mean the PMIC is bad or there's a communication issue with U8100 and SoC or other components. As of January 14th, this remains rare. I'm also going to put down here that communication issues can be caused by firmware issues because that's definitely a possibility. Anytime you have a PMIC that's not communicating with the SoC, that can definitely be a firmware issue there. let's see. Firmware issue also likely, note likely, I'm going to put a little asterisk because we don't know, but it just seems probable based on our knowledge of other boards. Because missing enable signals is from PMICs on the M1 machines. That again is rare. I haven't seen it yet. That does not mean there isn't boards out there with that, but it's definitely a plausible issue. Check VIN voltage. I mean, that's PP bus, so that should already, already be there. But I always recommend, if always double check by your chip, because sometimes you can have issues where voltages don't make it to some areas of the board. I've been trolled like that. It does go through a resistor. A current sensing resistor like this can blow, especially if the chip fails. So definitely a plausibility there. It's always one thing to check. Let's see. So if the above findings are negative and there are no shorts to ground or signs of damage, UC300 replacement of UC300 should be performed. Okay, that looks right. Now, our next one is, let me just open a new tab actually. I want to open a new tab for for 2237, just so I can copy some stuff that I already have here, because I really honestly don't remember what I wrote the other day. You never really do, so it's always nice to have a reference. So the next two voltages missing are 3V3 S2 UPC and 1V25 S2. Now the problem here is we really don't know how these present, because the weird thing about these is they all come from PMICs. If we look at, let's say, this other 5VS2, it does not come from a PMIC. So let's take a look here, 2016. So this here does not come from a PMIC. It comes from this power regulator, okay? Now the rest of these guys all come from the PMICs, and that's very complicated because a million things has to come online. Just so many things have to be right as far as communication goes between the PMICs and the SoC, and there could be so many issues there. So that really, really complicates things. I haven't seen, like I said, issues yet. So if you have seen something like this, go ahead and please add them below here on this page on the wiki. Anybody can go in here and edit this. So we are going to scroll down. Alright, now the next one was PP3V3 underscore, what did we say it was again? 3V3 underscore S2 underscore UPC. And we want this one bold. I'm still going to see how I formatted this here. Got it. Okay. It's from... Now I'm pretty sure this is going to be one of these guys. 3v5, let's see. 3v3 underscore. Yep, right here. I know it, U8100. It's produced from U8100, it looks like. It looks like this is actually an LDO. I probably went over this before, but I'm just going to double check here. I always like to be thorough, especially when we're writing a guide like this. But this seems like it's an LDO of some kind, not this. U8100. No, not that. I searched the wrong thing. I want... Yeah, so pin 176. That's probably not going to tell us much on the actual board view because VLDO7. Yep, voltage LDO, low dropout. So let's note that LDO produced from U8100. Now, this is a tricky voltage because it's dependent, like I said, PMICs, that they suck. They really, really, really do suck for stuff like this. Our next one, we're just going to chart down here, PP1V25 underscore S2. Double check, make sure I have that right. 1V25S2. And I honestly, I can't see these being missing in a lot of cases. The only time I see these missing is if there's a firmware issue or the PMIC is dead. And PMIC is failing. I mean, I'm not saying it doesn't happen. It's just not something you see often. I mean, it does happen, of course, but it's just not something that you're going to see very often. So this is going to come from, and this powers a lot of stuff. This powers a lot of stuff. A lot of very important stuff this powers. Yeah, you can really see how prominent this is on a lot of circuits. It's powering VDDIO sections. This is a VDD LDO for another one, so an LDO input. Yeah, this is a very, very, very important rail. And this is produced by U7700. So U7700. We're just going to note buck13 underscore LXO. U7700. That's noted. All right, now we got to fill in the troubleshooting on this. Now, we don't know. That's the thing. We don't really know, and one second here. Okay, so we don't really know what can cause these missing yet. I have never seen a personal case of it. I haven't heard of any personal cases of these being missing yet. But when we see voltages like this missing on, let's say, one, it really doesn't happen that often when we see a voltage like this. But when I think about, let's say, on a T2 board, when a voltage like this is missing, I think of PMIC issue, maybe firmware, but PMIC or firmware issue, usually I should say. So the first step is always going to be one, check for a short to ground, because that is the most common cause of a voltage like this being missing, is a short to ground. Now, where is it? It could be on many things, okay? We could have it on the PMIC itself could be shorted. This is Nothing, so that can't be shorted. The Wi-Fi IC could be shorted. This guy here, let's see, does this have a path to ground? Yep, that could be shorted. There's many things that have a path to ground on this, so a short to ground is always plausible when you have a path to ground. It can happen. It's definitely possible. So that's definitely a possibility there. And what we're also going to do here, we're also going to note in diode mode what the reading is on this, just in case there's something that's, let's say, pulling too much power there. So check for a short to ground. Normal. I forgot how to spell diode. Diode mode to ground. Reading is... Yeah, oh yeah, I've seen that many times, Christian. That's a common finding. I mean, I've seen that many times. Alright, let's grab an A20 2016 board out of here, and let's measure what that's supposed to be. This is not a 2016. Don't really have any lights on in my office right now, so it's kind of hard to see. And let's switch over here. Yeah, the nuke PCHs usually happen as a result of either... So I don't know exactly how they happen, but I presume either the clock chip stops switching in a way, or it shorts to ground in a way that... Alright, that's me right now. You can see my office is a mess. I didn't mean to do that. I want this right here. There we go. And I just need to kick on the microscope camera. So it could happen if there's an overvoltage into the PCH, or it could happen if, let's say, the PCH shorts to ground and it gets so hot so quick that the silicon just fractures. Silicon can fracture, and I mean, it's basically like glass, so it is subject to sharp temperature changes like that. So if you have something that, let's say, hang on one second here. Okay, so this is our line that we need to measure here. And I realize this might be a bit boring, but you know what? If I don't stream this, I'm not going to focus on it, and I need to get this done. So watch if you want. If not, it doesn't really matter. I kind of lost my train of thought there. Oh yeah, PCH. So anytime you have something like, let's say if there's a short to ground in it, and it gets very hot very fast, that can definitely cause it to do that. Alright, around 490. So it's around 490 in diode mode. So we're just going to note that, because if we have that noted, then, I mean, it can help out. Because sometimes you'll get something that, I mean, I know when something is too low. This was 1V25. Okay. Step 1. Check for a short to ground. Normal diode mode to ground. Reading is 0.4. Always need to do an about 0.490. Period. Now let's do 3v3. I always specify about, because what you'll get, and what I see in teaching and stuff, you'll get somebody that will see something. Let's say, okay, we have 490, we'll see we're on like 470. Okay, and they'll think that's abnormal, and they'll go chase something when there's not actually a problem there. So I always specify what exactly, or I always specify it's a range, it's about. And there's surprisingly, there is a pretty great tolerances in circuits. You could have different circuits, or same circuits on two different boards be totally different readings just through basically wear in the circuit. It's called electron migration. Alright, now, I don't know if my brain is broken or this is different on this board. Bryce is here. I am working on wiki stuff because I need to get it done without falling asleep. And okay, one's a no stuff. I see it now. Falling asleep while doing wiki stuff isn't the best of an idea. But if I don't stream, I'm probably not going to get it done. So, alright, about 420. 0.420. Got it. Zero 0.420. To ground. However, diagnoses, huh? That doesn't make sense. Got it. I was going to invite you to my birthday dinner last night, but I didn't want to be extra. What do you mean be extra? What was I even doing last night? I don't even remember what I did last night. I think I was exhausted last night. I was tired enough last night that I don't remember anything about last night. So, where possible to can include corrupt firmware where a DFU revive may resolve the issue, or a failed PMIC. This one, VV3 is U8100. U8100. Or an issue with the SOC. And it's basically going to be the same thing for 1v25 because we don't know what can cause this. Yes, I mean, when this is updated, then, or when we have more info on this, then I'll definitely come back here and update it. And this is the different one. Yeah, this one, U7700. 7700. It can be both the same thing. Could be an issue with DFU. We're gonna put a note here. This section will be updated when more M1 powered sent with similar issues. 18 2022 issues with PMIC voltages remain rare. Same thing. We're just going to do this because, again, we always want to leave a door open if we don't know. And here's the thing. I see a lot of people that are afraid to say they don't know. And it is totally okay to say you don't know. There's nothing wrong with not knowing something. Okay. Let's make sure everything's formatted right. Good. All right, we're going to move on to our next thing here, which is 5 volts and cycling, or 5 volts with cycling amp draw. So, 1 second. Okay, so problem 3, and this is something I've seen a couple times actually, and we're going to go back on my YouTube channel and look. No power, 5 volts, and amp draw cycling between 0.0 and 0.45 amps. That's fine. And this is, I've seen twice so far. S3. Okay. So I want to go back and let's look at our first. It's kind of nice documenting stuff on YouTube videos. If I didn't have a channel, I'd probably document stuff on. I'd probably document stuff. Oh shoot, no. I don't want to show anything. I don't want to show like stream key. So let's go back to our first M1 board, which was quite a while ago, actually. Here we go. Almost a year ago.
Hi, everyone. Tonight we have a special video. We have our very first M1 MacBook Pro.
And I look like total crap in this video.
You may be wondering, why isn't the customer just going to Apple for a warranty board replacement? Well,
Holy crap, 7,400 views.
on any of the new machines, if your board fails, your data's gone unless you could find someone who could properly repair the board. Since the storage is actually these 2 chips right here, these 2 NAND chips, so soldered to the board.
Now I know this is an A20 2020, but this 2016 and the 2020 are near a carbon copy.
Again, unless somebody can repair your board. So let's see what this does. So we're going to plug in our USB-C charger. Plug it in. Let's see. Alright. Looks like we get 5 volts on the charger, almost 100 milliamps, and the fan is running at 100% speed right from the start. So I unplug it, plug it back in, the fan doesn't ramp up, it just immediately spins to full.
Alright, that was a weird one. We'll note that, but this is going to be something else. Alright, I'm going to go on one that I didn't do on video. Okay, let's go. Who's that young child? That is Tim 11 months ago, and I've aged probably quite a bit since then. I've probably gained a few gray hairs just today alone. And the cycling deal is nearly always, I mean, I've only seen this when there's a short somewhere. I think, you know what? I'm thinking of the wrong video. It was this one. Wasn't this one. This one.
Now, on the previous machines, learning about these M1 machines and how they present on USB amp meters, so this will be yet another learning experience here. So, plug in our USB amp meter. Looks like we're getting 5 volts and 0.03 milliamps. Now, on the previous machines, on the T2 machines, that could mean PP Brush G3 hot is missing.
Okay, we covered this. Okay. And this is like nearly always a short. I mean, and let me look and see. I know the rail in my head. I know the rail if I look at the rail, but I don't know it off the top of my head. And let's see here. Hello, Caleb. I am back at the shop for unplanned circumstance. Okay, and I remember Caleb had a board that was it an A or no? It was a Pro. It was a Pro. It was a 2020. And the rail that was shorted, it was, I remember on the thermal imager, one of these coils was getting hot. It was one V8S2. That's right, it was one V8S2. And it was cycling between 5 volts and, it was 5 volts, 0.0 and 0.45. And it was this chip right here was shorted to ground, but this chip shorted to ground because of a short on this side of it. There was a cap. It was one of these caps right here that was shorted, so that overloaded this chip. This chip was shorting and the PMIC was shutting on and off. Okay, that's where that amp draw comes from. It comes from the PMIC trying to start, it can't, it restarts. So we're just going to put, I've only personally seen it on one V8S2. But I'm going to say if there's a short on any one of the PMIC's rails, it can do this. All right, so I'm just going to leave it broad. I'm going to say in most cases seen as of this date, it was PP1V8S2. But look at all the SoC stuff. So if the CPU dies, this is potentially a symptom of that. I don't know if this one can do it yet, but let's see. That's for RAM mainly, 1V25. Yeah, we're just going to leave it broad. These boards, Caleb, are not a scam. I would much prefer working on this compared to an older board. Let's see. We're just going to put nearly always caused by short to ground, particularly on a rail powered by a PMIC. PP1V8S2 being shorted to ground has caused this issue. However, other rails produced by U7700 and or U8100 can likely cause the same symptoms and presentation. The cycling amp draw occurs because the PMIC attempts to start the power sequence, senses an overload and shuts down. The process is repeated continuously. Period. Caleb loves fixing Dell and Lenovo no power stuff. And the reason why I know that is because every time he has one, he brings it here and it sits in my office for like 2 months and it gets thrown away. Okay, now let's see. Case report. We're going to do something a little bit different because this was a unique case. Case report. Case report 1. Case report example. 820-00-2020 presented Caleb, was this a liquid damage? I don't remember Let me think back. This wasn't the liquid damage. There was no liquid on the board. There was no liquid on the board. I remember that there was no liquid on the board. But how did that happen? The cap shorted. That's right. So probably what happened in this case is in this particular case, it presented with the complaint of liquid damage, but my guess is the liquid damage happened a long time ago. It was just over the keyboard or something. And the capacitor failed that we talked about, and it had nothing to do with liquid damage, so with no power. Inspection. Diffuse signs of liquid damage were seen on the system board or enclosure components. Thermographic imaging was performed, which revealed abnormal pulsation and enhancement of U8100 and U8100 and L8230 V8S2, a short to ground was measured. Did we inject voltage on this? I don't remember. Short to ground was measured. We did inject voltage. One volt and 5 amps was injected to the line, which revealed abnormal enhancement of, it was UC820. I don't see you writing any articles in L. UC820. UC820 is, what is UC820? UC820 is some kind of a switch. Yeah, 1V8S2 switch. We're just going to note PP1V8 underscore S2 to PP1V8 S2 underscore VDD1 switch. S2 SW. Wait, what? No. Yeah. UC820 was replaced, which restored 20 volts on the USB-C amp meter. However, voltage was, amperage was still abnormal at 0.008 amps. No. Okay. Some, heating of the CPU. When power was first connected. Was first connected. Further in visual inspection revealed it was a capacitor. It was one of these. I think it was this one. C1105 to have signs of cracking and excessive heat. A short ground was measured on PP1V8 score S2 score SW score VDD1. C1105 was removed with resolution of the short. However, function was not fully restored, and PP1V8 underscore S2 underscore S2 SW underscore VDD1 was still seen to be missing, despite normal VIN and EN aligns to UC820. Let's double check that number is right. UC820 to UC820. UC820 was replaced again, which restored full function of the board. We can conclude that in this case, UC820 was likely damaged from overload due to a short on its output. There. So we're just going to put differential diagnosis as short to ground on any of the PMIC of any of the PMIC output lines. PMIC buck output lines on U8100 or U7701. That's basically our differential diagnosis because I haven't seen it be anything else. In this case, thermal. I keep saying thermographic imaging, but thermal imaging. Let's change this to because someone's gonna not know what thermographic is. I know what thermographic is, but that's me. But someone else might not know, so we need to make this. Okay. Diagnostic steps. Let's see here. No, I wouldn't be the one to talk about stuff. You don't even know what a VPN is, so there's that. Diagnostic steps. 1. Check for shorts to ground, and you know what time it is next. We gotta do some diode mode readings. Check for shorts to ground on outputs of U8100 and U7701. And here we go. We have to start doing some diode mode readings to figure out what's normal on a board that somewhat turns on. So here we go. Let's open the 2016 board view because that's what I have in front of me. They're both the same as far as this goes. And I don't really want to do this, to be honest, but we're going to start with L8100. So L8100, normal diode mode to ground reading. This isn't typing to a customer now, so shut up. Okay, let's go. Okay, L8100. That's freaking low. 0.07? How many ohms is this? This powers the CPU. Let's just do a little thing here. So this, what's this called? PPVDD PCPU awake. PPVDD PCPU underscore awake. 0.007. That is freaking low, but let's see what ohms is, because I on CPU stuff I always like ohms better. Always ohms. Rather than diode, because diode is not accurate for CPU stuff. Slash go to ohms, and my meter just shut off as I clicked that. There it goes. My meter is rebooting. That does not sound good. Did I measure this right? Hang on. We got to double check. Oh, if you doubt your measurement in any way, recheck it. Nope, we're right. There's so many people that I've seen in this industry that are so stuck in their pride that they just won't double check something. Alright, so about 44 ohms slash about 44 ohm sign. I don't want to show, yeah. Yeah, we could do it. I like to round up about 45 ohms. If I say 44 ohms, it's more specific, okay? A CPU can read higher than that, it can read lower than that. It's all dependent on how much electron migration is taking place in that die. Okay, next one. L82. L82, alright, these are on the same line, so L82B0 and L82B1. L82B0 slash L82B1, which is PPVDD. PPVDD underscore eCPU underscore. Now, in chat, what do you guys think stands for pCPU and eCPU? What do you think is the difference between pCPU and eCPU? Oh, I'm not showing you guys. So, all right, let me go back here. OBS. All right. PPVDD, pCPU, and eCPU. Think about that for a few. And tell me what you guys think that means. Anyone? We don't know what this is yet, but we need to check. Alright, so what I believe this means, so the M1 has performance cores and energy efficient cores, and I would guess that the eCPU is the energy efficient cores of the CPU, and the pCPU is the high performance portion of the CPU. That would be my best guess, and I would put money on it that it's right. Alright, and these are just one single output here, so we're just going to measure here. So diode mode to ground, red probe on ground. I don't know if it's cold in here or if I have a fever. 0.114. Yeah, I really don't know if I have a fever or if it's cold in here. 4. Normal / ohms mode, ohms mode, ohms mode, ohms mode. $140 ohms. Okay, next one. These are the same. So L8271 and L8270. Wrong one again. Now you get to see me sitting in the dark in my messy office. The office isn't usually this messy, okay, just so you know. We have to take breaks and move stuff around while we're not doing videos that are important. E2. And this is called, what is this called again? PPVDD CPU SRAM awake. PPVDD underscore SRAM awake. See what? Hang on. I keep my short-term memory is really bad for stuff like this. PU underscore SRAM awake. Ground reading is 0. What? Let's find out. Always got to find out. You can't guess at something like this. And it's these last two coils there. Diode mode. .116 and ohms mode Alright, 450. Do diode motor ground again. That didn't sound right. Yep, 116. 16/450 ohms. Now, this board has stuff stolen off of it, or does it? Does it? Please tell me. Has this board been ravaged? It has been ravaged. Okay, so I don't know if we can trust our 1v8 reading on this. Yeah, I really don't know if we could trust that. Let me see if I can find a different board here. This is not an M1. Here's an M1 heatsink. That's an A15. Here's an M1 board. And do you have the chip that I want on you? Nope, you have it stolen too. Alright, this is when I ask you guys in chat if anybody watching this right now, does anybody have an M1 board that they could measure a rail? If not, we could just leave it for later. Here, Bryce can have mod. Okay. Carrying on. Nell, do you have an M1 board? Or is it cold in here? Or seriously, because it does not feel right. I don't know what the heck is going on. No, it is not cold in here, so that does not explain how I feel. I should not be having chills right now. Oh well. Someone's got to work. Alright, so our next one is going to be this guy. So L8120 and L8121. L8120/L8121, and this is PP something, PPVDD something CPU. PPVDD SoC S1. VDD SoC S1. SoC S1. Normal diode mode to ground reading is let's check. Anel's not asleep, I can guarantee you that. We should call him to see if he is awake, though. Are my chills multiplying? What does that mean? What does chills multiplying mean? I've never heard of that. I've never heard of chills multiplying. Probably stress, if I were to guess. Could also be the fact that I have not really slept properly in over a week now. But and it doesn't look like I'm going to be sleeping tonight either. 0.012. 0.012 slash what? How many ohms? 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 A 108 ohms. So we're just gonna note 110, like just round 110 ohms. All right, carrying on. Next one. What is our next one that we have to do here? We're done on this side, so we have this side to go. You belong to you. You belong. Okay. Let's do. This isn't gonna be fun. All right, so PCPU awake and VD. Okay. 3-phase, nice. All these are 3 phases. Oh, we already did this one. And now just this one. Alright, we got to make a note on PCPU. Now let me show you guys what I'm talking about because yeah. Alright, so I wasn't paying attention. That actually covers 4 coils. So we need to mark L81. We have L8100, L8101, and L8102. So let's go ahead and mark this right now. 100 slash L8101 slash L8102. All right, next one. Is going to be L8110, L8111, L8112. 8110 slash L slash L8112, and this is going to be something GPU PP VDD underscore GPU underscore awake. I'm guessing. Am I right? Let's see. Yep. Okay. Normal. Ground. Normal diode mode to ground. Reading. Now it's going to be low. I could tell you that much. It's going to be low. Any kind of CPU, GPU rails are almost always low. Missed a bracket after awake if you care. Bracket. Where is bracket? Where? Right here. Yes, I did miss that. Thank you very much. Do you feel I'm losing control over my mind, Bryce? Absolutely. 100%. All right. Just ask Caleb that. He could tell you that I've been losing my mind for the past, since he started working here. Wonder if the two correlate. Peter is here. Okay. 0.09 and how many ohms do we have? 36, 0.09, 36 ohms. I legitimately care about doing a good job on this because 0.00, was it 0.09 or 0.009? I do want to help. I'm not going to be fixing MacBooks forever. I don't know how. Honestly, I don't know how much longer this business will be profitable for. But at least if I decide to split out of this and go do something else, I at least want my contribution to help someone so I haven't just wasted all this time for nothing. Okay, next one. In that next one that we're going to do, it's going to be this one, PPVDD DISPS1. I think that stands for display, or display something. It might be a frame buffer in the GPU or something. That's what I think. So L8280 and L8281. Let's get this marked down. L82. See, I forget so often. Like when I just look at something like this, I just forget what's in my mind. L8280 and L8281. L82. One, and this is PPVDD. VDD underscore S1 underscore. Man, I cannot remember what this line was. S1, there we go. Normal. Ground. Move to ground. Reading is. Let's find out. Gotta find out. Okay. And this is going to be there. Got it. I really hope the thermal paste thing picks up. We'll see. I really did put a lot of effort into carbon black. And I can't measure this. Capacitor. Yeah, the thing about DIY tech damage is DIY tech damage sucks. And it's often screwed up in a way that, I mean, I'll take DIY tech damage almost every day over repair shop tech damage because it's much better than that. But how many ohms do we got? That didn't seem right again. I'm gonna double check. I wasn't paying attention which lead I put where. No, 0.055. Nah, something's not right here. Is my meter acting funny? Let's do PP bus, for example. What is PP bus? No, that's right. 0.5. All right. Yep. Okay. 233 ohms slash 33 ohms. Okay, next one is going to be, let me just check chat. We are measuring normals off of a iCloud lock donor board that otherwise functions and has one chip removed off of it. Well, it has one chip removed off of one V8 something, and then another chip, the trackpad E-fuse, which is not going to matter in this case. It's not like a true donor board. Yeah, Bryce, we see that from other repair shops quite often, actually, surprisingly. Okay. L8290. $82.90, which is what? L8290 is ppvdd underscore DCS. ppvdd DCS underscore S1. Normal ground reading is what? Is this going to be low too? Right, either of these capacitors right there. Got it. Alright, diode mode is 0.176 and ohms is 312. $310. All right, we have two more on this PMIC. I'm not going to go over every little major line on the PMIC because that's a waste of time. I'm just going over the coils just so we have a baseline. And can't click on OBS. PP1V4 LDO pre-reg. L84E0. L84E0. L84E. L84E0 is PP1V4 underscore 1V4 underscore LDO underscore pre-reg. What pre-reg is for, I don't know, but it sounds like it's lowering a voltage down in order to go into something else. Maybe the power input of this chip here? I don't know. It's a little bit odd, to be honest. Maybe something. Yep. Alright, that's where it goes to. Got it. And normal to ground reading is going to be what? I'm guessing this one's going to be high. Guessing fairly high. .285. I was right. 285 slash how many ohms do we have? Let's go back to our ohms mode. And ohms mode. Ohms mode, ohms mode, ohms mode. .30 kilo ohms and climbing. Alright, so we're just going to put greater than 30 kilo ohms, so. This is probably something I shouldn't say on stream. So, okay, so carbon black as far as thermal pad fills. I need to do more testing on that, but I have done some testing and it seems like it will work for 0.1 millimeter thermal pads. Anything thicker than that, I would recommend a thermal pad. I mean, thermal pads are something totally different than thermal paste, and I wouldn't necessarily recommend using a paste where a thermal pad should be, where a thermal pad is used. Although we need to do more testing, and I would like to see more testing on that. But I would say it probably can be in limited applications. I mean, it's basically what it's doing on the MacBook Airs that don't have, so hang on, my brain is on single core mode right now. Single core, single threaded. Okay. Yeah, so I would like to see more testing on that, but it basically, so one thing I can say, it does not work well on regular laptop CPUs or anything with a small heatsink gap. It's not meant to be. Just like if you were to scrape the original Apple paste off and put it on a CPU like that, it will work terribly. It's not meant for that. It's meant for really large gaps. So thermal pad replacement can be done. I mean, so here's the thing. Because of its large particle sizes, I mean, look at the size of the particles in the Apple original paste. They're very, 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 very large, probably 40 micron or larger. You don't want that on a thin layer CPU. It's Apple's paste is basically like a thermal pad. Okay, Apple's paste is literally like a thermal pad in paste form, and that's basically what carbon black is. But the gap is on the Apple heatsink is probably like 0.05 millimeter. So a 0.1 millimeter thermal pad is a little bit too big, but we need more testing on that. I have thought about developing another special aluminum-based paste for thermal pad replacement alone, but I have not really put much thought into it. But we'll see. But yeah, definitely a thermal pad replacement with carbon black is definitely a possible use of it, but I wouldn't know how well it works yet. I'm not going to make any claims of it working well yet in that application. It's really only designed for machines that use the black Apple thermal paste right now. And I will say this, so we have, I'll actually just go turn the lights off and talk about this for a second just because I want to give my eyes a break. So what we're doing right now, we're going to be releasing this video series. We're going to be testing carbon black against other thermal pastes on the 2018 MacBook Air. And how we're doing this, we're applying the paste. We're running 5 Geekbench tests in a row on with each thermal paste. And the problem is with regular thermal paste, there's something called and I don't want to get too much into this in this video because it's not related, but there's something called the pump out effect, and the pump out effect is greater on heat sinks with a bigger clearance. So last thing you want to really do on a heatsink that literally doesn't touch is use something with that, use a low viscosity paste that's going to pump out, because it's not going to work. So what we're finding is you may get fairly good thermal performance with something like MX4 initially, but after 2,000 thermal cycles, there's a chance there may be nothing left there to bridge heat over there. So we don't know yet. One thing I can say, and I totally will admit this, in testing so far, Thermal Grizzly has outperformed, Thermal Grizzly Cryonaut Extreme has outperformed Carbon Black, not by a huge margin. All right, so looking at temperature on modern Intel CPUs nowadays is not, you can't really tell how well a thermal solution is working by looking at the temperature, because they're going to boost up their clock voltage up to up to 100 Celsius. They're just going to keep raising it. The Thermal Grizzly Cryonaut Extreme, the pink stuff, worked incredibly well, and we actually saw a little bit boost in clock speeds under high load. So for example, it was about 100 megahertz gain over carbon black, and the TDP is roughly the same. Another thing that we see with carbon black is it starts out, the thermal performance does not start out great. If you first apply it on a machine and then let's say run Geekbench, you will notice you're going to score fairly low. And then as it heats up a few thermal cycles, let's say one Geekbench run, your next run will be substantially higher than your first. And Anel is calling me, and we're just going to ignore this call because I don't want to talk about this. So basically what's going on in there is that the paste changes viscosity. And if you look at the heatsink under the microscope on any of these devices that use this paste, they're very porous. Okay, now the thermal paste is thick. The thermal paste is fairly thick, as you've seen with it. It's very thick. And when it first gets hot, for the first few thermal cycles, the viscosity changes out, and the paste, the smaller particles in the paste, there's 3 particle sizes in carbon black. And the fluid in the paste, in the silicone, kind of changes the viscosity and allows those particles to flow into those larger crevices, and that most likely explains why the thermal performance is better after it goes through some thermal cycles. So for example, with Thermal Grizzly Cryonaut Extreme, one thing I've read about is, that I know about it that they claim is it has nano-sized aluminum particles, right? It's very small particle sizes, and that's not something you want in a huge gap like that due to the pump out effect. Because after so many thermal cycles, it's going to flow out, and even in 24 hours, we saw evidence of that happening, and you could see the washout of the material. We're going to have that video up later on, but that's not something you want long term. However, with Thermal Grizzly Cryonaut Extreme, we actually saw around. So right now, this has been running Prime 95 all day on carbon black. Our base wattage on the CPU is 7 watts TDP. It has burst up to like 16 or so, or turbo boost. It's sitting right now around 9 watts, which is still 2 watts above its TDP, and 2.2 gigahertz at its max, and 2 gigahertz at its average. With Thermal Grizzly, we saw 2.4 gigahertz max on some cores and 2.2 gigahertz average. The minimum frequency stayed at 1.8 volts on both tests, which is above its base frequency. So both thermal pastes were working fairly well in this application. But the thing about Thermal Grizzly, although it performs very well at first, in our durability test here that I'm just going to show you guys briefly. So this is our extreme durability test, and what this includes is heating the heatsink to around 300 Celsius in a controlled fashion on the BGA machine and seeing which paste dries out first. This was after 3 cycles, and I'm just going to show you guys real quick what the Thermal Grizzly looked like compared to what the carbon black looked like. All right, and one thing I'm going to do just to test this, okay, is I'm just going to drag a dry Q-tip. I just took this out. It's dry, right? All right, let's just rub this across the carbon black. All right, see how it's still like liquid? You could see silicone in it. Let's do the same thing on the Thermal Grizzly. Still there, but not as much. I mean, it's kind of dried out already, and you could look at the texture of it. I mean, it's kind of dried out. but again, that may not affect performance. But what I've read about the Cryonaut Extreme is it does dry out over time, and it's not really intended for applications over 80 Celsius. You can even read on their website that it says resists drying out and curing up to 80 Celsius. Now, that's not something you want on a MacBook, obviously, because that's sitting at 100 Celsius. So, however, the Thermal Grizzly Cryonaut Extreme seems like a better option than most other pastes because it's very, very thick. But again, I don't know how that would fare a long time. I mean, if you don't want to buy carbon black, probably Thermal Grizzly's Cryonaut Extreme is going to be up there as far as your choices go. But let me just go to chat real quick. Yeah, see, the thing is, Christian, anybody that buys a MacBook Air or something that paste is used on doesn't really use it heavily. So the Prime 95 or Prime 95 or even Cinebench isn't a good real world test. What somebody that buys this machine does is go on the internet. They go on the internet, and that's pretty much it. They use it for basic stuff. This is a dual core CPU. It's an Intel Y series, and believe it or not, a ThinkPad from 2012 has a faster CPU than this. A dual core from 2012 has a faster CPU than this. So I don't really like using Cinebench or even Prime 95 as a real world test because it's just not realistic. I mean, what I look for is in Geekbench. And what you can see, when we were doing our testing, we went from scoring in the 700s, which is basically like not having a heatsink, to the high 800s in single core score. And what you notice as far as like between Carbon Black and Thermal Grizzly is like the Thermal Grizzly would score like, let's say 1640, and the Carbon Black might score like 1605 or maybe 1595 or something like that. And if you look at that's really right on par with the stock paste. I mean, that's still high in the percentile, don't get me wrong, but it's right around with the stock paste, maybe a little bit above what the stock paste is. But the Thermal Grizzly did work really well. But the question is also, if you have a repair shop, is buying 2 grams of paste for like $30 practical on every machine? And 2, is it the best choice long term? I don't know. I'm probably going to say probably not, because it's really not designed for that kind of use. It's designed mainly for desktops that keep their temperatures down. And again, after just 24 hours, I did see signs of significant pump out. Let me just pull that video up real quick now that we're talking about it. MX4 is too thin. I'm telling you that right now. MX4 is really, really thin. And I know that's a popular one. If MX4 is too thin, Arctic Silver 5 is too thin. My chat keeps moving up on the screen, but I don't see anyone else typing. I don't know. Alright, so this is just a test we did. This is just pre-release video, so let me just find it real quick. Here we go. Alright, so okay. This is what Thermal Grizzly looked like after around 24 hours of use. Now, keep in mind, some of this is normal from the pump out effect. But, big emphasis on but, there is something that we can see here that is really not good. Alright, so we see the silicone, the oil on the silicone kind of warped out here. And this did not cover the whole die. So I could say this with 100% certainty. Nothing like Carbon Black covers the whole die. So Thermal Grizzly, I used a crap ton, and it still did not cover the whole die. Okay, what you can see here is the silicone oil weeping out, right? But one thing that I saw, you could see here, and you can tell by this characteristic pattern, is some of the filler in this kind of worked its way to its edges. And if that's happening after just 24 hours in this large of a gap, I cannot see this stuff lasting a long time. Now, the pump out effect is really, really common on high-grade thermal paste, and I'm not saying anything bad about Thermal Grizzly. The thermal performance of this stuff is excellent. Like I said, we had better frequency than stock, better frequency than Carbon Black off of this stuff. But I don't know on longevity on this stuff. I really, really, really don't know. But it's up to you. I mean, you use what you think is best. It's totally up to that. I mean, if I had a again, the thermal grizzly is not really intended to fill that large of a gap on this. Again, there is no heatsink contact on this machine, so I don't know. It definitely needs more long-term testing, but I definitely want to see side by side running the same parameters what the two pastes look like between each other. So let's see here. I'm getting tired, so I think I'm done. Let's see. What does Apple use originally for thermal paste? Apple on... Okay, so on the machines that I specify carbon black for, the MacBook Airs, the 2018 through 2018 to 2020 Airs, the RAM on the M1, okay, not to clarify that, the RAM portion on the M1, not the CPU portion, use this really gritty, thick black paste that you cannot get anywhere. Let's look at an example from it. And this is from another video that I'm doing on this. Okay, so on all these heat sinks that use this black paste, they do not touch. All right, so a regular thermal paste is not meant to fill something that does not touch. Thermal pads kind of perform crappy on an application that uses a CPU. It's just they can't dissipate heat quick enough. So Apple created this exotic thermal paste that's a mix between a thermal pad and a thermal paste. And there's nothing like it on the market. And that's why I think a lot of people were kind of giving me crap about it, is because they really don't realize that there's nothing like that on the market. They haven't worked on a MacBook, and a large majority of people don't know this, okay? So this video is not released yet, but I just want to show what the original Apple paste looks like. Let me find this here. Is this it? Okay, look at this. This is the original Apple paste on one of these machines. Okay, that is the original thermal compound supplied on many of these MacBooks. All right, and that's where the carbon black is designed to come in and replace. It's not designed to replace the gray standard thermal compound, but a large number, an increasing number, all the new M1 Pros, M1 Maxes use this thermal compound on their RAM portion. All right, and if you put regular thermal paste on the RAM portion of any of these machines too, it will not touch. Let me just actually show you this, because I have an M1 board right here, and why not? This is kind of just an informal talk and demonstration here. So, all right, so Tony, the Apple original paste is the Apple Black original paste is most likely lockdown, really a lockdown version, and it's most likely made by Shin-Itsu Micro C, which makes the regular gray standard thermal compound. But let's have a look. I want to look at this heatsink. I got to clean all the crap off of it first, because I was doing testing on this. And one thing people don't realize, and I try to get this across, but it just doesn't really click on a lot of people, is you can put MX4 on something. It's going to work fine. It's going to seem like it's fine, but over time, through the pump out effect, it's not going to be good. Just clean this off. All right, this is a dirty heatsink. Whatever. This was one we used. Do I have a different one that's cleaner, maybe? Let's see here. Do I have a different? Yes, I do. This one is cleaner. All right. So let's have a look at this. So let's take for example the M1s, and we're all going to be seeing M1s. Okay, so that's why if it was just on a 2018 MacBook Air, I wouldn't be doing this. All right. So the M1s that have the CPU portion, the CPU portion uses a standard gray type thermal compound, and the RAM portion uses the black stuff. Okay. Look at this heatsink. All right. What do you see? You see a part that's lower, which touches the CPU, then you see something that has a big gap there. Okay? And let's say, a thick thermal compound here. Now, keep in mind, when manufacturers of thermal compounds, this is GC Extreme. GC Extreme is pretty thick. Manufacturers of thermal compounds don't design their pastes to fill this large of a gap. Okay, so let's just, I don't want to squeeze too much out. Put a little GC Extreme on each one of these. All right. So that GC Extreme is a thick paste. I should say that. GC Extreme is one of the thicker pastes, and most thermal pastes are thinner than that. Let's attach the heatsink. Well, not attach. I'm just going to kind of set it down. Got to find the sweet spot. There we go. All right, so I just put this down. Now let's look at this. Okay. It's hard to tell, but it didn't really spread out. Okay, it made contact, yeah, but it did not really spread out from its point. Now, again, I'm going to do the same thing with carbon black. I'm going to use a similar amount. But the thing about carbon black is even if it does not spread out to that degree, it's made to transfer heat over large distances. Okay, it has the thermal filler content in it is insanely high. I don't want this to sound like a promo video. I just want to talk about this. All right, so let me just grab a little bit of carbon black, same amount. And this is live. I'm not faking this. I've had some people that have said that I'm faking all these tests. All right, just put that much. And look at the consistency. I mean, it's very close to the Apple original paste. And another thing we did is we realized, you know what? People aren't really going to understand, you know, how much to put on there compared to other stuff. So, let's see here. I really don't know why they designed it like that. So the thing is, these devices that use this large of a gap need a lot of paste too, and I don't want somebody putting too little, so we went with a syringe that has a nice big applicator that lets you put plenty on. Too much is not a problem. Too much is not a problem at all. Let's go ahead and put this on with carbon black. I'm going to switch this again and see it. Now, this stuff starts out thin, but after a few thermal cycles, it will become thicker and around the similar consistency of the apple paste. That's not considered drying out. All right, so I just put it on, right? And notice another thing. There's a seal here. I'm picking the board up by the heatsink, right? And let's take it off. And look at the difference in that spread pattern. I mean, you could immediately tell that it made contact compared with the GC Extreme, which it looked like it just didn't touch. So again, what we look for in spread patterns is if the paste kind of spread out towards that. And you can compare this to the original Apple paste, but it is very close. We did make some changes that we could have made it closer to the Apple paste, but I didn't want to for spreadability reasons. But I mean, this stuff is close to the original apple paste. And another unscientific test. All right, this is a very unscientific test, but it is a useful test when you test about how well a heatsink will conduct heat away from when there's a huge gap there. And now, if you were to measure the watts per meters Kelvin of something really thick and really thin, the thinner one is going to be better every time. But the thing is watts per meters Kelvin really doesn't matter that much in real world application. Like it's you could have a paste that has, like, let's say, I don't know, like I don't even know where the watts per meters Kelvin stands in this because I'm not going to waste money getting that tested because it's not going to do anything different. You could have something that's, let's say, 1 watts per meters Kelvin perform better than something 15 watts per meters Kelvin, depending on the application. It just doesn't matter. So the really unscientific test that you can do is put a big gob of paste on here and just lightly touch your iron here. So my iron is just sitting in the paste, right? And I could already feel the heatsink getting very hot to touch. All right, it's not even touching; it's just resting on it. And that's the thing about other pastes, is they're not really meant to bridge heat over that long a distance for a long time. So, you know, that's why we designed this. And there seems to be a need for it if people will actually buy it and realize, you know, what's the difference between it and other stuff. Anyway, let's go back to chat. And I'm getting tired. I think I'm going to get out of here. Carbon black does look like tar, just like the apple paste looks like tar. I like to spread my paste CPUs and GPUs manually, so it will All right, Tony, let's look at something real quick because the Tony, great point, and this is going to be addressed in a later video, in our promo video. It's probably going to come online tomorrow. I'm just waiting on Injured Gadgets to list it. Let's spread out some thermal paste, and live is the best way to do this because if I do it pre-recorded, somebody's going to say I faked it. Let's grab a board. Let's grab a board. Here, let's see. Actually, this one probably has a dead CPU anyway. Actually, this one, yeah, I did some testing on this anyway, but it has a dead CPU, so it's fine to use. So, Tony, I want to show you why you can't spread this out, and anyone else in this watching this. So, hopefully everybody stays here to see this. All right, so our heatsink is clean, and one characteristic, I don't know why Apple has this. I have an idea of why they did this, and it does make somewhat sense. The original Apple thermal compound will scratch the hell out of the CPU. And this is when we did some testing with Thermal Grizzly just on spread patterns. But the whole point of that is if you have a particle that kind of digs itself into the top layer of the silicon, it's going to transfer heat better than if it's just sitting on top. And that does make sense with the type of heat sinks they use. It's not harmful to the die or anything. They're very superficial scratches, but it does make sense. And the carbon black will do that too, to a lesser degree. So anyway, let's use some GC Extreme because I have plenty of stuff. All right, I'm putting more than enough. I'm putting a ton on there, honestly. We can all agree that that's more than you need to cover a CPU. And let's spread this out. We're going to spread this out even over the CPU, like Tony said. Hopefully everyone's still here. So here's our thermal paste. Just spread this out over the whole die. And the pump out effect still comes into play here, even if you spread it out. Okay, this is spread out over the whole die like everyone likes to do. Okay, we could all agree this. All right, it's spread out. Here's our heatsink. Now I'm not going to put the screws in the heatsink, okay, because we don't really need it. I'm just going to put pressure on all four corners right here. So I'm putting pressure, I'm moving it back and forth. I'm putting quite a bit of force into this. There you have it. That's what it looks like. It doesn't touch. And the only spots that are actually getting paste on it are the thick areas of paste. There is zero physical contact between this heatsink and the CPU. Okay, and that's why you need a thick paste. And that's why Apple specifies these special thermal pastes from the factory. If you use, like I said, I went over this. If you use a regular thermal compound, it will make some contact. If you use a gob of thermal paste, it's going to make some contact. If anybody's worked on this, on any of these, you see how the thermal paste contacts the CPU. It doesn't make good contact. It will make some contact, but give it several thermal cycles, and the pump out effect is going to move a lot of that CPU, a lot of that paste off of the CPU. It makes no sense why they would do this. It really does not make sense. From an engineering perspective or anything, it doesn't make sense. Or what they did is they realized they screwed up. Oh crap, we made a heatsink that doesn't touch it. I think they did this on the A1534s. It clearly touched. Really, does this look like what clearly touching? Oh, it's a no. Of course it's a no. Alright, so let's just put a regular amount of thermal paste. Let's just do a big glob in the center again. I'm probably boring people because I know people didn't come here to watch thermal paste demonstration. So that's a pea-sized amount. I mean, that's what we normally use on a CPU, especially with a square die. Okay, I'll do it again. And it's kind of nice to do this live because people can see that it's not being... Okay, and it's spread out. Okay, it did spread out somewhat. Thicker paste will spread out better, but it did not spread out over the whole CPU. Okay, there's a very large gap. There's a large gap there. And the whole point here, again, Yes, something like this, like GC Extreme or MX4, Arctic Silver 5, all those will work in the start, but after so many thermal cycles, they're not really going to work. The pump out effect is going to remove a lot of the filler material out, and it's going to move a lot of the paste away, and then you lose contact completely. And when you use something thick, it just doesn't tend to happen in the same way compared to with a thinner paste. So Tony, this is not a custom PC thing. This is an Apple only nonsense thing. You're not going to see this with custom PCs. You're not going to see this with anyone else than Apple, because usually other companies know how to design a thermal solution. And then I'll show you guys something really, really briefly. This is a really early test sample of something. I do kind of like the idea of manufacturing thermal paste. It's relatively simple to do once you get your formula down. So this is a prototype of TC7310, which is going to be like our OEM equivalent thermal paste. Now, generally the higher viscosity paste resists the pump out effect better than lower viscosity pastes. This is something that it is nowhere near done. It still needs a lot of fine tuning and a lot of work, but this is what paste we're probably going to be coming out with in the next couple months as well is going to look like. So I don't have an exact date for this. Again, it is still very, very early in development, but that's what that's going to look like. And that's not intended for use in applications that need carbon black, of course. This is just a standard thermal compound with small size particles, as you can see there. That should work well in many applications, including custom PCs. But again, it's fairly early in the development phase, and it needs a lot of work because in its current state it is not very good, but it will be in time. So, but that's that. And also, one of the things that I've got was, people don't want to buy a 10-gram syringe of thermal paste, especially carbon black, when they only use it maybe once or twice a year. So we are also going to have 2-gram syringes coming out. So that should help a little bit for some people at a lower price. Anyway, I'm getting tired and my brain isn't really... Alright, so Bryce has a good question. With MX, would it have to be replaced more often? On, let's say, a 2018 MacBook Air or something that uses Apple's black paste, it would probably have to be replaced every month. If they're using it every day, the pump out effect is going to be substantial after even just 1 month. You saw with something like Thermal Grizzly, which is very, very high up in the viscosity range, the pump out effect was very prominent after, a day. So with MX, again, alright, let me put it this way. If you don't want to buy carbon black, use a thermal pad. Use a 0.1 millimeter thermal pad and cut it to the length of the die. That's the best option for the MacBook Airs or anything else that uses that black Apple paste. Thermal pad performance is going to be less. You're under high load, you're going to have some frequency drops, but it will work better than standard paste. Standard paste may provide better performance at the start, but give it some time and the performance is just gonna plummet once the pump out effect is more prominent. One of the things with carbon black is it doesn't all thermal paste suffer from the pump out effect, and so all thermal paste suffer from the pump out effect in some way. OEM paste do too. On the original Apple paste, you can actually see the silicone oils around it sometimes. That's totally normal. That's just something that happens, and that happens with carbon black too. If you run the heatsink, if you run the device hard for quite a while and then take the heatsink off, you will see the silicone oil around the paste. That is totally normal. But what I'd like to see is that there's minimal thermal filler material in that effect. So even if the paste loses some of its oil, and that's not technically drying out, okay, because silicone paste really don't dry out, if you would. A lot of them stay thick, and that's fine. But you don't want to see a large amount of thermal filler washed out with that silicone oil. And like I said, it's gonna, after so long, so I would say probably with carbon black goes, after probably about a month or two of uses, it's gonna have a fairly, it's not gonna be dried out. I shouldn't say dried out. It's going to be hardened, and not hardened, not like glue hardened, but it's gonna have a very similar consistency to the apple paste. Now we could have had the same consistency as the apple paste off the bat, but if you do that, it becomes very, very hard to spread. It becomes very, very hard to apply, and that's not what you want. So anyway, I'm going to check chat one more time now that my rambling is over. And alright. Alright, what if you design better heat sinks to go with the thermal paste? Alright, so if you designed, that's a pain, and that's not, yeah. So okay. Let's think about something. So, what are those orange boxes and shelves? Those are stuff that Caleb got behind a dumpster that are probably going to end up being useful here. And anyway, we're not going to worry about what those are right now. Okay, those don't pretend these are not here for now. All right, those do not exist. They're not back here. What was I totally lost my train of thought. All right, so yeah, designing heat sinks for each one. So you would need a solid block of copper or a solid block of aluminum for each one. You would need a CNC, probably a mill and everything to manufacture a heat sink. It would probably, if I were to guess, let's look at what a solid block of copper, because or a solid block of aluminum. It's going to be expensive for that. And let's see here. I better save this. Let's save this before we forget. There is no water in the ocean. Really? Horses do not have feathers. No, a horse does not have... Does a horse have feathers? Am I really that tired? What a scam. What the hell? I'm logged in. Why? Whatever. Minor edit. Next. Save. Yes. There's water in the ocean. Yes, it snows in Canada. Alright. This is no good. This is really no good. No, don't even tell me this. I need to save this. Oh, no. Alright. No. I can't even copy all this. Alright, U81, added many readings. U8100. Oh, this would be bad. This would be very, very bad. No, a cat cannot read a book. Ah, yes. Okay, that was scary. Anyway, going back. Copper. Alright, let's look at what a solid block of okay. This is how much copper costs. Okay? It is not a cheap material, okay? Making a heatsink would be very expensive, let alone the cost of, like, what am I saying? All right, it's just not practical to make a heatsink for every device. To change a heatsink on every device versus to make a similar thermal paste. I'm not going to go into what it costs me to make a tube of thermal paste, but it's a whole lot cheaper than this. Okay, it's a whole lot cheaper than this, and this could probably make like it's a 1 inch by 4 inch copper bar. That could make like maybe like 3 heatsinks. No, it's not going to be practical in any means to do that. So anyway, I'm getting out of here. And furthermore, another thing to think about making a custom heatsink is Apple could claim that you are counterfeiting a part for their computer, and that's going to get you in legal trouble. You don't want that. So, all right, I'm out of here. But yeah, it's much easier. And another person commented, "Well, you went through all this effort to create a thermal paste when you could have just used a copper shim." Using a copper shim is not a good idea because you could put too much pressure on your CPU and you could crack the die. And furthermore, the CPUs really don't like when they're made for a precise amount of pressure, and I would not, without knowing how much force you're exerting on the die in the package, I wouldn't, honestly. You're changing the whole flexation profile of the board by adding a copper shim like that, because you have your heatsink anchors. You're putting a lot more pressure in that part of the board. That board is screwed into the enclosure. I wouldn't. I mean, especially after drops and everything, I would not use a copper shim. Could you achieve great performance with a copper shim compared to like just using carbon black or just changing the thermal paste? Probably. I mean, you're making it so the heatsink actually touches the CPU. But the risk involved is high, and it's not practical for a repair or repair perspective point of view. Think about this. Let's say you have numerous devices coming across your bench. What's easier, grabbing a copper shim, fitting it into the little thing, putting regular thermal paste, putting it down, or just grabbing another thing of thermal paste and just replacing how it's designed from the factory? I don't know. I like to keep it, despite the design being crappy, I like to keep things close to original. I don't like when I see stuff that's not original. So I like to keep things original in the most part. Anyway, let me check chat one more time, and then I need to get out of here because I'm tired. All right, so Tony, I want you to think about something for a minute. If your gap is too big and you sand it down, you're removing material, what's going to happen? You're making the gap larger. Sanding it is not going to fix it. Sanding it is not going to fix it. If you sand it down, you are going to be removing more material. The whole issue is that the gap is too big. So you might have a gap this big, right? You sand it down, now the gap is this big. You just made your gap bigger, you made your problem bigger. Sanding it down isn't thing. And then another thing, practicality. Do you really want to sand down a heatsink every single 2018, 2019 MacBook Air you get? It's not practical. It's much practical just to do a thermal paste. I mean, the thermal paste, for what this costs, so one of these tubes costs $30 plus shipping, $8 for shipping. This should get you like 50 applications, 30 to 50 applications, I should say. I've never measured how many applications exactly out of a tube, but this is a lot of applications. I don't understand why people are so hard-headed about buying a tube of thermal paste instead of just or wanting to modify everything on every single job they get rather than just buying a tube of thermal paste. I don't understand it. Anyway, yeah, it's just, I really don't like the copper shim idea. If you want to do the copper shim idea, by all means, go do the copper shim idea. But I don't like it. I really don't like that idea. Again, when you put, so the heatsink, this heatsink does not put a lot of pressure on the CPU. I don't know what went into the engineers' heads to do this. Was the whole idea like, oh, we want to make the device perform worse? Probably not. There's probably something that went into that idea, and it probably has something to do with how long and thin those boards are, and it probably has something to do with the flex. All right, so if you take something that has no pressure on it, and then you're putting pressure right here, and you have pressure on the screws, and the board is kind of being flexed, I don't know. I can't see into the future what happens there, but that's not something I would want to do when I'm putting a 1-year warranty on a board. I don't know what the long-term effects of that are going to be. I don't know if the board is going to develop a cracked trace. I don't know if the board is going to develop cracked solder balls. I don't know about if there's just so many unknowns on it. It doesn't make sense from a repair point of view to do something like that where you don't know the effects of it. And a lot of people don't think about that. They don't think about what they're changing when they put a copper shim on the board. They're just thinking, oh, it makes the heatsink touch. No, you're changing so many different factors on the board. You're changing the amount of pressure that's on the CPU. You're changing what's going to happen if the device is dropped. You're changing what's going to happen when the board is torqued down into the enclosure and the stress points on it. There's literally so many factors that are going to be changed from something simple like that. So it doesn't make sense for me to do it. And it's much easier just to replace the thermal paste. That's me. Let's see. Yeah, it could definitely be a flex issue, and we've seen this in the past. We've seen this on the U8900s. I've heard that I've never seen this personally. I've just heard rumors of it. The A1502s, you know, those little heatsink those rubber stickers. I've heard that those put pressure on the CPU for some reason. Another thing, let's see if I have one here on the A1932. I feel like the engineers suspected. Here's one. This is a bad example. A better one than this. So, yeah. So here we go. So the A1932. Now I don't know how many defects there are like this, but what I do know is Apple does have a defect department where they analyze failures on boards, and one thing I've noticed on 2019 and newer machines, they've had these things on them. All right, 2018 didn't have them, 2019, 20 had them, and the M1 Airs had them. Okay, it's a rubber thing that makes contact with the grommet, and there's multiple on here. There's one here. There was another one. I know there's many of these. There's a couple of them on here somewhere. I don't know where the rest are, but these prevent the board from flexing. All right, and that makes me think that they anticipated flex issues on this. All right, maybe that went into something on their heatsink design. I don't know. There's no way of knowing unless we talk to the engineer that designed the board. But again, I wouldn't make modifications like that. I wouldn't think it's a viable option to do it. Sanding the heatsink is definitely not a viable option because you would have to add more material. And when you do add more material so it even touches, I mean, the precision you would have to get that down to where it's just touching to a thin layer or just having a very, 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 very small gap, the precision that would go into that would just be insane. It's just not practical. I mean, by all means, if you want to engineer that, or if someone wants to engineer that, go right ahead, but it's not. It's, from my personal opinion, it's not feasible to do, especially if you handle a lot of volume. Anyway, I've been checking chat for the last time for a while, but this has been a good discussion, and this was actually a good discussion. Anyway, I don't know why anyone wants to remake the wheel when you already made something that works. If your thermal paste works, just use that. It's much easier to use thermal paste. True. It could be a flex issue that makes a lot of sense. Those screw posts are held in with solder after all.